Is this thing actually? Yes, it is. Thank you. Well, I'll tell you the advantage of this room is there's actually air here, unlike down with Raymond in the spaghetti room. But I'm glad to see a number of you at least made it up here. I recognize at least a couple of you who were in his previous session down there. So my name is Magnus Hagander. I work for a company called Red Pill Inpro. We're a open source consultancy company up in the Nordic region, focused mainly in Sweden, Norway, and Denmark. My focus area is the PostgreSQL database engine, but I also do a bunch of development work and some of it in Python, which is sort of why I'm here. We have other people who do a lot more Python than I do. So I'm going to talk today about data-driven cache invalidation, which obviously everybody knows exactly what I mean, right? Sort of a quick recap on what we're going to get into here. We all like to build advanced websites, right? That's sort of who builds non-web applications these days. And we want them to become popular. And hopefully, they do become popular and then they crash. And then we add some level of caching to make them not crash. And then we get a whole bunch of other issues that we need to deal with around that. This is a way to deal with these issues that will show up when we add the caching, because caching will make it go fast and make it not crash and make the users complain that they get the wrong data. That's sort of the basis of it. And well, it used to be that websites came down from the slashdot effect. I don't know if anyone in here has experienced it. I'm not sure even the slashdot effect counts today. Slashdot doesn't drive that much traffic. Featured on like national TV in the US drives traffic, like spiky traffic, with another 100 million users within half an hour, things like that. That's the kind of deals that we actually have to take care of today. So when we're talking about the caching, we're already caching at a lot of layers. You're probably caching in a lot of these layers already in your application, and it's basically from bottom down, where if you're using a database server, whichever one you're using, you have a cache in it, at least one. You have the buffer cache that's in the database. Some databases, particularly if you're deploying on MySQL, you may have a query cache that also runs in the database. And then you have some sort of a cache in your application server, whichever application server you're using. And then you might be using an HTTP cache ahead of that. And then you're caching in the browser. So we basically got all these layers of caching. And the closer to the client that we cache, the more efficient the caching is, right? If we can just keep the cache on the client, they never have to talk to us at all. That's very good for the bandwidth bill. Unfortunately, the further away you go, the harder it is to actually control when things leave the cache. And that is the problem. If you cache every page, you can cache the front page of your website in the browser for a month. You'll get good dealings with the load, but if you're posting any kind of updated information, your users are really not going to like that. So a typical architecture of your web app, sort of drastically simplified, is something like this. We have a whole number of clients out on the internet. They'll be connecting to your cache. Your cache will be connecting to your application server, whichever it happens to be, which will at some point hit your database. Most applications are one way or another database driven, the way things are today. And what we're trying to make it all happen is, the typical, I'm sure you already know this, you got a number of GET requests that is trying to get what's basically the same object. You want to minimize that down to a single request in your application server, or at least very, very much fewer requests in your application server, which will then result in one, or usually more than one, but at least a limited number of queries on your database server. So you sort of push the stopping point for the large number of requests as far away from the hard-to-scale part of your system as possible. And the hard-to-scale part is the database. So in this presentation, so how many people in here regularly, or at least sometimes, give presentations on any kind of topics? Okay, so how many know the golden rule about demos in presentations? There's a rule that says, you should never do a demo in a presentation, right? And I'm subscribing to that because I think we're doing about 5 or 6 demos. So hopefully at least one of them will work. So please bear with me if the demos halt at some point, but eventually I'll probably get it through. I'm going to do a very, very simple application demo for this. We're going to do an extremely simple blog. We all know what that works. We all know how it is. And we're all really popular people, so we're going to be talking about at least a couple of million hits a minute, right? We post interesting things on our blogs. So, intro to the application. I'm a Postgres guy. I'm going to use Postgres. You can use, in theory, any database with it, as long as the database has server programmability into it. You can do this out of Oracle. You can do it out of SQL Server. You can probably figure out a way to do it in MySQL as well in the later releases. I'm going to use Django as the framework, which is probably no big surprise to you guys here. It will work with any framework. I've given this presentation at a lot of non-Python events. It'll work with any one of them. I choose Django because, well, A, Django admin makes it really easy for mock-up applications, and B, I like Python. And as a cache, we're going to use Varnish. How many people in here know about Varnish? Okay, at least a number of you. The rest of you probably heard of things. You can use Squid or Apache Mod Cache and all these like HTTP caching. We're using Varnish because, well, A, it's silly fast. And, we're talking millions of hits a minute here. And it's also very customizable, and you can interact with it very well, which is exactly what we're going to exploit to make this stuff work. So, like the good, TV chef, I've prepared a number of steps. I'm not even going to show those to you at all because you guys know Python already. I'm going to focus more on the database side, but I've started a simple Django project called Demo, put an app in it called Blog, configured to a local database server. I'm running, embarrassingly enough, Postgres 8.4, which is a couple of years old now, but it still works for this, so it's no sort of cutting-edge technology. I've enabled the Django admin site and given myself the application, put it into the admin site as well. So just to show what we have for start here, I'm going to see if I can get out of full screen mode, and hopefully we have a reasonable aspects on this stuff. We have a very simple model for blog posts that basically has a title, date, time, and contents. And it's, which one is that? It looks somewhat like this. It's probably readable enough to you guys, right? It's a very simple model that basically has no functionality other than these three fields. That's the only thing that's in it. Yes, when you do go in production with this blog, you might want to add a couple of more features to it, but this will have to do for now. And we've put that one into the admin side, synchronize the database. We have all the objects, and I've created two simple Django views. One that is the homepage, and one that just lists all blog posts, and one that serves up a single blog post. So again, let me show you the code because it's very simple. It's quick to show. It's just the typical. Let's get all the post objects ordered by datetime, render them off root.html, and then for a specific post, just get the post and render it with a template. And a quick example of how the post template looks. As you will notice, there is no fancy HTML, CSS, or any stuff like that. I'll leave that up to you guys to add later. Again, I'm a database guy. I don't do this sort of visual stuff. I work with data.
Can you unmaximize the...
I can try to unmaximize the window, because that is slightly too unmaximized, I guess. Let's see if I can grab that one and see where the screen ends. Something like that. So anyway, it's the simple part. We have the post title, we have the post title again, the contents, and then I've just added to all of these. They're in the other templates as well, a simple generated at with the exact timestamp when this page is rendered. That is a very good way to see if your cache is working. So we've added those. Not bothered with any sort of the fancy URLs with part of the title in it. We're just using the numeric ID. That's the simple way of getting this thing done. I'm going to stay in this mode, I guess. So actually, how many people in here have been using Django at some point? Okay, good. So you're fairly familiar with this. We have the manage.py run server, which will run a very simple local web server. If we run this, it will eventually bring up. Now, interesting thing, if someone knows why, this tends to freeze every now and then when I run it locally. Just completely freeze and require a kill-9. So if you know why, let me know. Yep.
Probably signal handling thread or something.
Probably, but...
So that could hook up, hook S-trace up to it.
Yeah, probably. Usually I just restart it, because, it's the local. If it was on a server, I'd be worried. Though I probably wouldn't be using this manage.py thing on a server. So, here's what the blog looks like. I've put one post into it. Marvel at the screen size. There we go. marvel at the fantastic design. We have this one blog. If I refresh this thing, you'll see in the window, actually, well, it goes sort of off the side there, but every time we hit this one, we get a request here that hits the Django application. We know that this generates one query back into the database. I could enable query logging on the database and show that, but I'm not going to bother doing that. We'll just have to take my word for it. And of course, if I click this blog post, I get the details. And again, I get this generated at, which updates step by step. So that's the basic functionality of this application. As I said, probably you'll want slightly more advanced applications in production, but it'll do for showing this. So we're in the position here that every time we do this, we generate a run of the Python code, which is comparatively slow. Now, for rendering this, it's not that slow. You can probably render a fair number of hits per second. We're also throwing a query at the database every time someone comes to our blog. So what we're going to do to avoid this, to keep the load down on our server, is we're going to add varnish to the mix. Turns out it's actually really, really easy to add varnish to a very simple website, and then, of course, it becomes progressively more complex as your website grows in complexity. I'm going to do very simple, basic default varnish install. It's going to take any request that comes into the varnish, which is going to listen on port 8001, and just relay them back to port 8000. And it's going to cache all pages for 1 hour. Now, the biggest problem around caching is usually dealing with cookies. In that, if you have a session cookie, you actually don't want the page to look the same for every user. I'm just going to ignore that for now because this is not a varnish session. You can learn that when you go to a presentation about varnish. So I've got an example. Here is the full configuration for the varnish. This is for those of you who haven't actually used varnish. This is the VCL, varnish configuration language. Varnish is basically configured by you write a small program using a domain-specific language where you define a number of functions. So in this case, I just first have a definition that says my default backend, which is where varnish is going to relay the data, is going to run on localhost port 8000. And the subroutine VCL resv will be executed every time a request comes into varnish. And I'm just going to remove the cookies from the request if there are any, thus ignoring the problem. And VCL fetch is executed every time varnish gets something from our Django application. At which point I'm just saying, set the TTL to 1 hour. So we'll be caching these objects for 1 hour. And I've got a very simple, I'll just show it to you so you know what it looks like. The start script for varnish is nothing magic. We say start varnish, listen on this port. For the moment, I don't remember what -f is, so we'll just ignore that. -t is we want a telnet administration interface. So we can just telnet to the machine and give it status information. Running on 6082. We're using a memory allocation backend with a 32 megabyte cache. That'll be enough for this trivial blog. And I'm just directing it off into a temporary disk. Okay, so let me just... okay. For the sake of demo, I'm stopping varnish and now restarting varnish. I forgot to stop it from when I tested this demo. Okay, very simple. We have varnish running. It'll tell you there it's got a max size 32 megabytes. Well, I can move it up there. Even the information is not all that interesting. So if I now bring up the web again, and I have my blog here on port 8001, as you can perhaps see up there. And if I refresh here, it did reload. I have no idea really where it picks the time zone from, because it seems to be picking a different one every time. I haven't bothered investigating. Or it may simply be that I put the wrong escape codes in the template. The point being, if I refresh this now, you'll notice that the generated at does not change. And if I bring up my Django console here, we'll move it in so it sees, so we'll just put a couple of spaces in there. You'll notice we had this one request here at 647. And I refresh again here a couple of times, and we have exactly nothing happening in the Django. Now, this is all good. The problem around this, obviously, is let me go into the admin interface and realize that this post is actually not test, it's test 2. Save it. And we go back to the blog, and it's still test. That's your classical caching problem, right? Now, I cached it for an hour. I don't have that much time in this talk, so I'm not going to show you, but you'll have to trust me that varnish will actually stop caching it after 1 hour. For the sake of this talk, that's infinite, right? And really, infinite caching is the best. assuming we can somehow change our mind. And that's what we're going to try to do here. The problem is, the general we have, that some of our content will rapidly go stale. If you look at your blog, for example, the top blog post might go stale after 30 seconds when you find your spelling error. Other content is very, very long-lived, such as, well, first of all the other blog posts on your front page that you're not going to edit anymore. And also the first blog post once you've fixed the spelling error, unless you find another one. The big problem there is you don't actually know ahead of time how long this thing is cacheable. So how do we do that? Well, we generally end up caching things a very short time, just to be on the safe side. Because when the people from, if it's not our simple blog, but our actual business application, when the people from the whatever department handles your content makes an update and it doesn't change on the website, they will call you and say the website doesn't work. They will not wait. Even if you told them, wait 5 minutes, they will never wait 5 minutes. It doesn't work that way. This means that any kind of cache control that you're setting on a per URL basis or even on a per request basis are going to be suboptimal, because by the time you're serving up this blog post or the front page of your website, you don't actually know how long you can cache this information. You can give it a reasonable guess, but you don't know. And the usual thing you have to do is you have to decrease the caching time, which then kills your performance. So the way to deal with this is on-demand invalidation. You cache objects longer than you can, generally. And then you make a forced expire from the cache. Now, we're pretty used to doing this if it's in the database, it does it automatically. If we're using a caching framework in our application server, we have good frameworks for doing this. But usually when you're deploying an HTTP cache, most people don't do this. For one thing, if you're using older HTTP caches like Squid, the way to do this is basically filled with pain. There's no really good way of doing it, but it is doable now. The idea being when an object, we're used to dealing with objects, particularly here when we're talking Django apps or whatever, when it's modified in the application, we want to expire it from the HTTP cache. And when a dependent object is modified, we want to expire it as well. So we sort of want to track that whole relationship through it. And that's actually pretty easy to do in Varnish. And that's a very standard thing. We just add something called a purge request, which we can generate in our application server. In Django, we can use the signal that gets fired whenever we save a model. And we can just have that one tell Varnish, oh, hey, I modified this object, go away. And that'll work just fine. And that's a reasonably common deployment pattern, and it has one major problem in it. Does anyone spot the major problem in it?
If the purge request fails, do you have more than one cache server?
Those are the minor problems, I would say, yeah.
You're missing an arc from the database to Varnish, so you don't notice if the data changes in the database.
Yes, that is pretty much it. Your reality may look like this. Particularly, it looks like this when you're building this project, right? And it may even look like this, 15 minutes after you deployed it, but you're eventually going to end up in a situation like this. You don't have just one application towards your database. You will have multiple applications talking to your database, whether you like it or not. The application may just be, your DBA administrator using pgadmin talking directly to the database, or eventually it's going to be somebody else also talking to your tables. So the problem here is, we will only know about the events that happened in our own application. We cannot react to things coming in from elsewhere. Now, yes, for our blog, probably that's fine. But for most of your business applications, it's not, even if it is fine when you start, it's not going to stay fine. And just as you said, what we want to do here is want to move this arrow. Because if you look at the image, there is actually a very central point here, and that's the database. Okay, the database will know when your data changed. That's sort of the point of the database, to keep track of that. Now, with any kind of, I was going to say modern database, but with modern in this case, I guess I mean something since the early 80s or later, is capable of triggering on events happening to your data. And we can exploit this to invalidate our cache based on the actual data being changed. The upside of this is that we're actually going to be able to do exactly the right cache invalidations. We know exactly when the data is invalidated. We can, in theory, even do a synchronous one. Normally, we'll do an asynchronous cache invalidation, and we'll be up to speed within milliseconds. and it doesn't matter where this change comes from. It's from your application, it's from another application, it's from a manual change, it's from a batch job. It'll just magically work. I like magic. The downside is that you actually need to tell your database about your URLs, and that kind of breaks the abstractions. Because there is no such thing as a free lunch, and that's the price that you have to pay. If the database is going to expire things from your cache, it has to know where they are. Now, there are a couple of workarounds that will work depending on exactly how your system looks, that you can actually get rid of that. But in the general case, you need to put more information in the database than you previously had, and that might not conceptually actually belong in the database logic. But it's doable. And it's usually a price worth paying when we go to this. So the very simple way, the method 1, as I like to call it, is that we simply put a trigger on our blog post table, and we have this trigger send off a purge request to Varnish to remove our objects. Pretty simple. So let me show you what this code will look like. That will be trigger 1. So how many people in here are used to Postgres? Okay, good. Then this is not entirely. The rest of you have at least seen an SQL database, I hope. Okay. So we're going to be using 2 languages here. I just put the create language statements at the top of my script, so I don't forget to run them when I run the demo. We're going to use EuroPython. And the main reason for using that is actually not that this is a Python conference. It is that Varnish comes with a built-in Python module that lets you expire things through a very nice API. So I didn't have to write my own wrapper. And we're going to use PLPG-SQL, which is the Postgres built-in stored procedure language. So first I just have a function up here, the function varnish purge that takes the URL as a parameter. It's written in PLPython-U, and it does, as you can see, it's from varnish admin import varnish admin. That's the wrapper object. We just instantiate the object and run purge on our URL. Luckily enough, this 127.001:6082 happens to be the default here. Otherwise, obviously, we'd put something into the constructor telling you where the varnish server is, which usually your varnish server is not running on your database server. So you'll probably want to have something like that. And then we create a trigger function. The way the triggers works in Postgres is you have a trigger that always calls a trigger function. So the trigger function here is the blog post trigger function. Returns trigger, that's how we always do it if we want to create a trigger. Language PLPG-SQL, and we say begin, and we're going to do for any blog post that's changed, we're going to send a varnish purge for the root page. Varnish purges take regular expressions against your URL, so you can put anything you want in there. So any update is going to purge the home page, because for this blog application, we're actually rendering every blog post on the front page. And then we're also going to purge the slash and the ID of whatever row has been changed in the database. And then just add a slash at the end of that. And then this is something that's easy to forget, return new. If you don't do this, all your updates will fail, because that will be a return null, which tells Postgres, hey, this trigger said I shouldn't do this. I'm just doing a drop trigger if exists, again, so that I can actually run this script more than once without things failing. And then we create the actual trigger, create trigger. I'm calling it blog post trigger 1, because I'm going to show you another one later. On blog post, for each row, after insert or update or delete. So whenever anything changes, for each row, execute blog post trigger func. That means if I go into the admin interface and just change one entry, it's going to execute blog post trigger func once for that entry. If I go in and do a bulk update, sort of update all my titles and set them to foobar, because I did it in the wrong database, it's going to execute that function multiple times automatically and just generate multiple expiration requests. Now, if we have a database with many different models, many different tables, then yes, we create many different triggers. They're still going to call the same varnish purge function. But for each individual model that's being triggered on, we need to know which URLs to get rid of. So just to show this, I'm going to run the script. This is the standard Postgres command line interface, for those of you who haven't seen it. And you will notice that, yes, I'm running a very old version. Not only am I running 8.4, I'm not even running the latest version of 8.4, which I really should be. That's what I tell my customers. But at least I'm running the 9.2 development version of the command line client. So let's see, I got trigger1.sql. I just run this script. Well, it'll tell me first, error, the languages exists. It created my 2 functions. It didn't drop my triggers because they didn't exist. Well, it dropped one of them, sorry. And then it created the new trigger. So now we have all these objects loaded in the database. And we can go back to the web here and see if this thing is still where it is. Yeah, we're still stuck at 6:47 in the morning at some kind of time zone. So we haven't been able to expire it. But if I now go in and say, let's change this thing to test 3. Hold on, test 3. Save it. Refresh it, and it will have actually updated. And now once we've done that, I can keep refreshing. The new object is now in the cache. That is how easy the simple expire is. And now we have the same issue if I go into this page here, test 3, go in and edit it to test 4, go back here, it has updated. Got both the title and the generated at. Now, by default, if I actually go in here, edit this thing and change it back to test 4, I think that Django actually resaves the object, so we expire it. You can put that logic in the trigger as well to make it not expire the object if you just saved it back with exactly the same contents. Though it's even better if you can change your application so it doesn't save it back with exactly the same contents. That's kind of unnecessary. So, that is the method 1 that you probably aren't going to be using. Because obviously there's a reason why I have a method 2 and a method 3. Can anyone spot a big problem with this one? Yeah.
You need to map your model with, you have some information in your model in Django, and
yep.
you have your URL somewhere else, so you need to change at least 2 stores.
Yes, that is unfortunately a basic problem in this model, that you have that knowledge. Now, you can actually, given that we're writing these functions in EuroPython, if you can serialize, you can import your Django code into your stored procedure and sort of get it out of there if you have a good way of doing that. So that is doable, but it's not so it's a correct answer, but not the one I'm looking for. The biggest problem with this is assuming you have a lot of people editing this. You're going to be firing off, a lot of varnish purge requests. These requests are firing off while your clients are waiting. So assuming the connection between the cache and the database goes down, your clients will be waiting. Well, if it goes down completely, you'll get an error. But if the network connection hangs, your client will be waiting. We're doing this inline synchronously inside our transactions. That's probably not the best idea. It also makes it really, really hard to process the fact if you have multiple caches, because you need to solve that problem all on your own. The most common way of doing this in Postgres is to use something called asynchronous notifications, in the way that we'll create the trigger on the blog post table, just as before, but instead of firing off the varnish purge, this trigger actually inserts the URL it once purged into another table. And this table has another trigger. And this trigger fires off something called an asynchronous notification. Now, this is a Postgres extension to SQL, whereby basically you have an SQL statement called listen and another one called notify. So I'll have a daemon running that is connected to my database that says basically listen varnish purge. That's all it does. Whenever somebody runs notify varnish purge, this daemon gets signaled. It will then query this queuing table and execute varnish purges on those. And that works pretty well. But what we're doing here is, it's pretty obvious what this is, right? It's a very simplistic message queue. And it works in limited scenarios, but it starts becoming troublesome if you're ending up with huge amounts of purges. Now, hopefully you're not going to end up with huge amounts of purges, but the fact is, it's also a lot easier to use the fact that somebody already wrote this code for you. Because we created a trivial queue. Someone did it. The easiest one, we're in the Postgres context, we're in the Python context. There is a message queue that runs inside of Postgres called pgqueue. It is part of a package called SkyTools, developed by Skype. It is the foundation of the replication engine that Skype uses to replicate their data across all their servers. which means it's very high performance because they really need that. It's very efficient, and it will take care of your problems. It will also automatically take care of your dealing with multiple caches. It'll just do that for you. You don't have to care. It'll offload things. It'll make sure your database stays efficient. It'll automatically run things like vacuum as required. It'll rotate between multiple tables. It'll take away the corner cases around MVCC snapshots that you just don't want to have to care about. So I'm not even going to bother showing you method 2, because method 3 is just as easy and much nicer. So to use PGQ, well, PGQ, say it's a package, it's part of SkyTools. If you're like me, I'm running Ubuntu here. It's packaged up in Debian and Ubuntu by default. It's just a package called SkyTools. There are RPMs available, obviously, for Red Hat packages or Red Hat platforms. Once we've installed the SkyTools themselves, we need to install PGQ into the database. It basically creates a schema and stuffs a bunch of functions in it. So I'm going to be doing that, and then we're going to create our queue, because we can have a single PGQ installation can deal with multiple queues. We're just going to have one for our purchase. And in PGQ, it's vital that you have something called a ticker running. This ticker process is just sort of the maintenance process of the queue that makes sure it doesn't get stuck and takes care of all this rotation and snapshotting and things like that. So actually, did I remember to... I did not remember to do that, so let me just open up. There's a very simple PGQ configuration file that looks like this. PGQ ADM tells me the defaults for my admin tool. I'm just going to say my job is going to be varnish ticker, and here's my database. Into the cache demo, and I have my queue called varnish purger, which is in the same database. You just need to list every queue once by default, the way this guy looks. So to install PGQ, I just do PGQ ADM. Notice the .py. The entire SkyTools framework is written in Python. There are a couple of sort of low-level C routines for the super high-performance stuff, but everything else is Python. It does always take the ini file as the first parameter and then just say correctly spelled install. And we've installed PGQ in this database. If I now look through in my PSQL, list my schemas, it has created a schema called PGQ that contains all the things I need. It means if you want to get rid of it, just get rid of that schema and everything is gone. So having done that, we're going to create the queue, which, what did I say it was called? Varnish purger, right? Yep. So I, again, run PGQ ADM, create varnish purger, and it's done. And finally, we needed this ticker that just keeps things running. So I run it again and say ticker. This is the part, okay, I don't actually say create ticker. I say ticker. Now I have 2 queues. I only need one, but there will be another one showing up in all the status displays. Sorry about that. The ticker you'll normally start from your init script to make sure it's always running. If the ticker is not running, your queue will not work. So you need to monitor that thing too. Okay, so we have the ticker running. Now the way PGQ works is we have you post events to the queue, and you have something that's in PGQ terminology called a consumer that receives these events. And the idea is we write a very simple consumer. It consumes events from PGQ. It will post them as purge requests to Varnish. And the idea is if we have multiple Varnish servers, we will run multiple consumers connected to the same queue, and then PGQ will make sure that they're all executed. So if I have 3 of the consumers, it'll make sure all 3 are run. If one of my Varnish servers is offline, well, as long as my consumer correctly notices that it's offline and doesn't say I've processed this event, PGQ will retry this over and over again until it suddenly starts succeeding. Now you can write these consumers in pretty much any language you want. Now since SkyTools is written in Python, for some strange reason there are very nice Python libraries available with it. There are very nice Python libraries. There are fairly crappy PHP libraries and nothing else included in the package. I know someone has written, there is something on CPAN for Perl. But we're going to look at the way we write this thing in Python. And it turns out, again, we don't need much code because most of this stuff is written for us. We're just importing PGQ, which is where we have all the classes and functions from PGQ. And we're again importing this same Varnish admin functionality, and we create our class, and we just inherit from pgq.consumer. And that will take care of 99% of our glue. We're going to override a method called process batch, which is, we can also run this on a process event basis. PGQ will group multiple events into a batch to make things run faster. We'll receive them as a batch as well. And we're just going to run this batch. We get an EV list, which is a list of all the events that we need to process. The first check here, just if len EV list, is that we don't want to instantiate this varnish admin object if there is nothing at all to do. We might get a completely empty batch, and then we just want to ignore it. Because as we instantiate up here with the v equals varnish admin, that will actually open a connection to the varnish server. So we don't want to do that if there is nothing to do. We're then looping over all of our events and say, you know, whenever we receive an event of the type purge, we're going to print that we're going to do it. We're going to call the purge, and then we're going to say ev.tagDone. It's this tagDone thing that takes the thing out of the PGQ queue. So if the v.purge call fails, at this point our entire consumer will crash, but that's what happens when you don't put proper handling in, right? You'll put some sort of exception handling around it when you're doing this in production, and you just need to make sure you don't do ev.tagDone if it failed. Because once you've said tagDone, you're never going to see the event again. And then we're just saying, you know, if we receive anything else on this queue, then we don't know what it is. We're not supposed to receive anything else, but we could. And finally, we just instantiate this by the default of the default in all the Sky tools are you pass this INI file to everything. So we're just taking that in, and we're saying run the queue or run the consumer on the queue varnish purge. So I'm just going to start this thing here by saying consumer.py and pgq.ini. And it doesn't actually do anything, right? Because we haven't posted anything. It is now up and running. It's listening to our queue. So at this point, we need to rewrite the trigger to talk to this PGQ thing. And luckily enough, that makes things much easier. We don't even need PL-Python. Because PGQ, again, it's a queuing system that is well integrated in the Postgres engine. So it exposes itself as functions in the database. It also has a Python API, of course, so you can post these things without being in the database. But we're just changing the blog post trigger func PGQ instead, that takes exactly the same rules. As you can see, the first row, we use the root, and the second row uses the root/id/. And we just use pgq.insertEvent into the queue named varnish purger with the tag purge. And these are the events that eventually pick up on the other side. And I've just changed the trigger here to, instead of being blog post trigger func, it's now blog post trigger func PGQ. So let me find this one and run the replacement thing. And it does the create function, drop trigger, blah, blah, blah. So now have this one running. Let's see if something has happened in our consumer. One event has shown up in our consumer. This just happened to be completely random. It has nothing to do with us. There is another one. These are the events that the ticker generates every now and then just to keep the system in sync. You will notice it says count:0. That's we got a batch, it was empty. If we look at the ticker, it has generated a number of ticks. Some of them go to the consumer, some of them don't. They're just sort of the heartbeat of the whole system. Now, if I go into my web again, where's my web browser? There is the web browser. We can go change this thing and change it into test 5. And we save that. Let's see if this works, or if I forgot the step. It did work. And if I now look in my consumer, you'll notice we did receive an event with count 2. And we executed the 2 purge requests. And we didn't have to do anything else. PGQ took care of the fact that this now runs. It's kind of hard to show on a laptop, but it does run asynchronously. If you get a huge load spike, yes, your purges will be delayed by a couple of seconds, but they will end up running. If I shut down Varnish and purge something and start it up, it'll eventually, within a couple of seconds, notice like, hey, there's a retry queue here, and fire off the purchase on that one as well. Obviously, you can use any sort of queuing. You can use like RabbitMQ or whatever if you already have it in your system. The biggest advantage of PGQ is that it's entirely integrated. So if your system is running on Postgres already, then you have the server side. It's for free. Now, if you're using something like RabbitMQ or whatever, there are server-side modules for Postgres that lets you easily post these things onto those message queues as well, but you have one more server's type to maintain at that point. And like I said, this is the foundation for a high-performance replication system, so the performance is perfectly fine. It's not as good. Yes, RabbitMQ will be faster. It will scale more for pure queuing. But if you are expiring that many URLs from your website, you might want to rethink exactly how you're dealing with things. Another advantage of PGQ is that it needs almost no hand-holding at all. Okay, as long as this ticker thing is running, it'll take care of everything, which means monitor the ticker. There is a PGQ ADM status command that, actually, let me open a new window here. If I just run this one with status, it will tell me, well, first of all, it'll tell me that I have 2 queues. I was only supposed to have 1. But it tells you here, first of all, rotation 3/7200 means PGQ is rotating through different tables for performance reasons. By default, it'll rotate after 7,200 seconds or 500 events. I think it's something like that. This just says, well, it has received 3 events. It's got some ticker information on exactly how often it ticks. You got the ticker lag, which is currently, you can see it's 40 seconds since we saw a tick on one of them, 47 seconds since we saw it on the other. The last value that's at 60 seconds is how often we will always generate a tick. So if the T lag, it goes above 60 seconds, you have a problem with this queue. So we'll run this again. Hopefully the lag has restarted because we did receive a tick. And for each of our queue, we will actually see all our registered consumers. So if we had 3 varnished servers, we'll have 3 consumers listed down here, and we'll see when they were last seen. Again, this should also not climb in these times. That also means that if you actually uninstall a varnished server, you need to go remove that, unregister that consumer, or your warning system or your monitoring system will start alerting on the fact that, hey, this guy hasn't purged anything for 5 weeks because you decommissioned it. And that's pretty much all there is to the hand holding. There is already, I know, at least a Munin plugin for monitoring this. And there's probably at least 100 people who've written their own little 5-line Nagios plugin. Of course, again, this is Python. You don't need to use pgqadm.py. There is an actual API if you want to access it from your existing monitoring system, where you can just extract this data. I'm going to go back to full screen for a second. So there are a couple of rules, and there's one thing that may help you avoid this fact that you need to push the URL knowledge into the database, and that is the fact that Varnish is actually capable of purging not just based on the URL, but based on any HTTP header on the object. Okay, so you can put your own kind of tags into the headers as you send them from your Django or whatever application into Varnish, and then later reference those tags to purge it. And again, we'll just use a regular expression against this custom header. So one way of doing this that you can see, for example, if your site is posting something, you can just add an x-obj. Please put an x at the head of your header name if you're inventing your own. You're not supposed to, that's what the HTTP RFC says you should do. Don't use somebody else's header, just create your own. So x-obj, in this case, I'll just say news:123, news:124, and user:42. So basically, for every page you render, you tag it with which models and the primary key of that model. So you will then know that when you update news number 124, you send a purge request for news:124, which will then have a regex, but says, well, probably it's going to say news:124, comma, to just be on the safe side. And you can purge against that. Now, this does not work for every application. And it's not reasonable if your x-obj header actually ends up being 500 objects long. But in some cases, it will work. It might be best to use a combination of these two. But this is actually a pretty good functionality. Now, another thing that you should not forget to do in this case is to strip this header off in Varnish. Right? There is no need for your client to see this header. You'll just have your deliver command in Varnish just remove it before it's sent off to the client. You need it to be stored in the cache so that we can expire against it, but you don't need it all the way up in the client. So some final words around this. Don't use it unless you have to, right? If you can reliably set an expiry time on a URL, because you know that it's valid for a certain amount of time, then by all means do that instead. Okay? It will be more efficient. Use the smaxedge, the cache control HTTP headers, set them in your application. Varnish will follow their command and do what they're doing. So use this purging when it's needed. Because you really don't want to do this 1,000 times a second. It'll work. It'll work fine. Varnish will deal with it. And the PGQ will deal with it. But you really need to rethink your strategy if you're expiring things from your cache that often. Most people really. Then maybe you need that page to only be cached for 1 second. Because even a 1 second cache will do a very, very good effect on things like the Slashdot or the national TV effect. Caching it for 1 second might cut 99.5% of your traffic. You won't get the last of it, but you will get a lot of it. But it does work. It does scale pretty well when you do need to use it. And use a combination. Use cache control on the URLs that you know. Use purging on the URLs that you don't know. And running this from within the database will make it stable for the fact that you will eventually have multiple clients. So as one final word before I say thank you is, wow, this is the first time I think none of the demos actually crashed. Must be because I'm at a Python event. Thank you all. Yeah.
How would you handle...
Sorry.
Oh.
How would you handle things like you invalidate something like you have a huge structure and invalidate the top node of the huge structure and need to push out like 100,000 purge requests because you threw out your structure?
Yeah, depending on exactly how your URL structure works, if you can collapse this into a lower number of regchecks, that's really what you want to do. You don't want to put 100,000 purges out there if you can avoid it.
Yes, but you would get 100,000 probably trigger events on the queue.
Are you actually updating 100,000 rows in the database?
No, but I need to invalidate so many possibly.
Yeah, but what you can do there is you put that logic already into the into the function that you're calling in the database, right? You put that logic already in this function. At this point, you get called on if you updated one row. And this can then recurse into your data structure and figure out exactly what needs to be expired.
Okay, thanks.
And then generate a hopefully less than 100,000 number of purges into it. If you push it all out to the consumer, then yes, you have that problem. Then it's sort of too late.
How do I use PGQ when I have multiple database machines, like master, slaves, or multi-masters?
For this, normally you'll be running it on your master, because on your slave you're not firing triggers. Multi-master is a very special situation. It'll depend on your multi-master solution. For example, if you're using, say, Bocardo multi-master, you can use hooks in Bocardo instead to fire this, rather than using an actual database trigger. Because if you're using the actual trigger, it'll sort of conflict with the triggers that Bocardo is using, but then put it in the hooks that system provides.
Thank you.
Okay. Get one over there.
Seeing as Varnish executes those purge regular expressions when requests come in, isn't it better for Varnish to have fewer, more broad purges than lots of more granular ones?
That depends. I mean, more granular ones will make you expire less. But yes, I mean, if you're going to end up purging 50,000 records, then you might be better off doing a broader purge that accidentally takes out 75,000 records. Yes. But the flip side is obviously, 5 specific purges compared to, let's purge everything is obviously a big win in that case. So it's.
Do you think there would be some way of consolidating lots of those purges down on a regular basis?
Oh, absolutely. It's doable. I mean, that's one of the things that I suggested to the gentleman over there. Like, you can actually do it at this point if they're generated in the same transaction. If they're generated in different transactions, well, you can put it in your PGQ consumer that it sort of collects up for a while and runs the purge every 10 seconds. And it's got a big list of things that's basically Python list that you can apply some magic and sort of consolidate the regexps. Just doing sort of generic regex consolidation, I don't know if there's anybody who does that, but knowing your own structure, you might be able to take some shortcuts and actually make regex consolidation a reasonable thing to do.
Just continuing on with that idea, what might work is to have hash buckets and create, say, 100 buckets for each of your entities and just delete those, because the chances are removing 1% of your cache isn't going to have much of an
absolutely.
effect.
And then you can send the sort of bucket ID along as an HTTP header and just kill off on that. Absolutely, that's also the... Again, that means once you sort of leave the, I'm going to do it by URL space, it's going to be application specific, which way is the best way to do it. But anything that you can make deterministic, you can stick it in an HTTP header and then expire based on it.
Just thought you could use a bloom filter.
Well, you can also, I mean, you can use a random number generator. It'll be fun. Okay.
Anyone else?
There you go.
No?
Okay.
Thank you.
Thank you very much for showing up.